Goed. Goed, dan wil ek net graag vir julle voorstel aan ons spannie vanoggend. So hier agter die masjiene staan Ina Smit. Ina werk op navorsing, nie net in Suid-Afrika nie, maar ook in Afrika. Sy het 'n baie groot projek daarbey betrokke. En dan agter in die hoek dan kry ek my ander kollega werk, meneer Tsepo Majaki. Tsepo sal ook nou 'n bietjie met julle praat en net vir julle wys eintlik hoe interessant kan wetenskap wees, en dat soms praat jy oor een en maar eintlik praat jy oor 10 ander sonder dat jy besef. Ek hoop julle gaan saam met hom dink oor die goed wat hy vir julle sê. Nou my ander kollega, meneer Floyd Masimona. Floyd is 'n intern by ons, so ons het ook interns wat by ons werk, wat baie lekker is, en veel van hulle werk blootstelling voor hulle die baie wêreld ingaan. So, en dan het ons ook iemand van die departement van hoër onderwys en opleiding, wat vir ons net vir so 'n bietjie gaan vertel van TVET colleges, want ons weet is al wat groot ene vir verdere opleiding. 'n Bietjie die beurse, 'n bietjie die geleenthede wat daarbey betrokke is. So Ina, as ek net vinnig my
kan ek opsit? Okay.
Dankie. Gesien ek net asseblief. So, net so 'n bietjie oor die organisasie. Ek het dit besig gehou. Ons Ek gaan net bietjie verduidelik wat doen ons. Ek dink dit is baie belangrik. Soos ek julle gesê het, ons elke jaar gee ons 'n goue medalje vir die beste navorser in die land. So is nie net goed genoeg dat jy net navorsing doen nie. Dis fyn, ons almal kan navorsing doen. Ek kan julle ook nou agter 'n rekenaar sit ek julle tema gee en sê doen vir my navorsing. Maar hierdie ouens is nogal baie spesiaal. En dis hoekom hulle goue medalje is elke jaar is baie soos Engels gesê prestigious om hom te kry. So hier's nou 3 gesigte, ek weet nie of julle hulle ken nie. Maar professor Kareisha Abdul Karim Sale, so vele mense sê Ina, hulle is by die Universiteit van KwaZulu-Natal en hulle werk met bekampen van vigs en HIV/AIDS en so aan. En hulle het ook 'n bepaalde gel ontwikkel wat baie effektief is om dit te bekamp. Professor Jonathan Jansen, hy is ook ons president op die oomblik van ons organisasie, maar hy was die rektor, dat die rektor is soos 'n skoolhoof van die Universiteit van Vrystaat. Maar hy doen verskeie baie in opvoedkunde, veral in basiese onderrig ensovoorts. Hy is baie kontroversieel, jy moet 'n bietjie net in die koerante kyk. Hy doen baie kommentare en hy is eintlik verskriklik krities teenoor die totale stelsel. So hy het ook 'n goue medalje byvoorbeeld gekry. Brian van Wilgen, hy werk op biologiese oplossings in die land en hoe dit in 'n gemeenskap kan teruggevoer word. Die tweede ding wat ons doen, is ons doen ook navorsing. Ons kry panele bymekaar en dis natuurlik dan al hierdie navorsers wat ons lede is en ons kom op met 'n verslag. Ek weet nie of julle weet nie, maar wat is die grootste probleem tot onlangs gewese graafvryheid? Toe graafvryheid sê die ander. Wat was die grootste probleem? Daar was aksiegroepe, daar was 'n geboudery en hulle het betoog en hulle het opgekom. Wat was dit? Ek kan nie hoor nie. Al die droogte is een ding en dis die klimaatsverandering waaroor ons gaan praat. En dat was 'n baie groot ding gewees. Die antwoord is amper daar. Dit gaan oor om te boor in die aardkors en dan gasse van onder uit die aardkors uit te trek. En al die petroleumorganisasies soos Sasol en nie Sasol eintlik spesifiek die BP en Shell het eintlik gesê dat weet julle daar in die Karoo net aan die ander kant graafry nie. Is daar 'n plek waar ons kan lekker diep ingaan en ons kan daai gasse ontgin. Maar die probleem is met die gasse is dit maak verskillende omgewingsskade. En jy diepers en jy droog verskriklik diep in. Jy kan nie dit aan die skade wat dit op daaronder en die bietjie water, waar's my meneer wat gesê die droogte. Nou die ondergrondse water wat nou nog steeds bestaan, dit word heeltemal geruïneer en die kontaminasie ook van gasse en water kan jy nou dink is 'n probleem. Toe het ons gegaan en ons 'n studie gedoen en ons het gesê, okay, Hoe gereed is Suid-Afrika vir hierdie tipe ding? Julle moet net so 'n bietjie as julle so 'n bietjie op die internet speel, gaan doen dit hydraulic fracturing. Gaan kyk net hoe lyk so 'n aanleg. Dis verskriklik. Dit is soos 'n myn en wat myn hulle, wat doen hulle en die damme wat hulle nou moet uitlê om die water uit te pomp, om uiteindelik daai gasse uit te pomp. Dis 'n skrikkelik dramaties vir die omgewing as sulks. Toe sê ons studie nee, Suid-Afrika is glad nie gereed hiervoor nie. As ons dit enigstens oorweeg, moet dan ons studies gedoen raak. En wat het gebeur so 3 weke gelede, weet julle? Die lisensies is nie goedgekeur vir ons self of enige van our petroleumorganisasies om die fracturing te doen. Want dis die werk wat ons doen. So ons adviseer op die regering en sê, asseblief, huishouding, moenie dit doen nie. So dit is baie belangrik eintlik daar vir ons. En dan wat ons ook moet doen, is wat ons vandag doen. So ons praat ook nie oor wetenskap in 'n lekker manier, is dat hulle miskien moed kan kry en kan sien hoe geïntegreerd is wetenskap as hulle in jou lewe. Ek het 'n tweede dogters en hulle studeer argitektuur en dat altyd vir my fisiekale geneem om ons wiskunde doen en hulle moes tegniese tekeninge doen. Ek sê hulle, "Ma, hoekom doen ons hierdie goed?" En net nou die dag, toe draai sy om en sy sê vir my, "Dankie tog, ek het die wiskunde gedoen. Dankie tog, ek het materiale op skool gehad. Want alles werk nou vir my. Miskien nie direk nie, maar I'm getting it." So dis baie belangrik dat 'n mens daaroor ook praat. En dan natuurlik doen ons ook 'n baie wetenskaplike joernaal. Hy is een van die bestes in Suid-Afrika, South African Journal of Science. Hy is net aanlyn beskikbaar. En dan wat ons ook hier by julle skool gaan los, is dan vir julle toegewyds. En ek wil die juffrouens asseblief sê, kom kyk dit in julle sentrum of julle hom ontvang. En dan meneer Morris, asseblief ons wil die adresse van hierdie skole hê dat ons hulle elke keer as ons publiseer vir hulle daarom 'n paar kopieë kan sien wat julle in julle sentrum gaan hou. Vandag is ons belangrike dag. Ons quest online, is aanlyn ook beskikbaar, soos jy toegang tot die internet het, kan jy daarna kyk. En daar's alles. En ons tema dan nou vir hierdie week is natuurlik klimaatsverandering. So ek wil nou net sê, dink net 'n bietjie aan, soos ons aangaan, ek gaan vir julle roep nou. Dink net 'n bietjie oor wat doen julle hier in die mansdorp, wat klimaatsverandering teenwerk. Hoe voel jy daaroor? Dink jy daar so 'n ding soos klimaatsverandering? Dink jy daar is 'n ding soos klimaatsverandering? Of wat dink jy dit? Dis okay as jy twyfel, want ons gaan kyk hoekom sê ons daar is klimaatsverandering, wat presies beteken dit? Julle wat geografie neem, moet dit verstaan. Daar's 'n baie belangrike konsep daarso, en ek gaan nie sê wat dit is nie. Ons gaan kyk of julle dit optel en dat julle dit vir once for all dit in julle kan onderskei. Dit is 'n belangrike verandering. So, nou wil ek baie graag weet, is dit 'n lyste wat sirkuleer met julle name en goed op? Ek is jammer daaroor, maar ons het dit nodig om ten minste ons befondsing te wys. Ons was by die skool en ons het hierdie werk gedoen. En wie is die leerders wat ons gesien? So ek is jammer daaroor, maar asseblief ons sal baie bly wees as julle dit kan doen. Dan is dit nou eintlik meneer van Jacques.
Good morning. Just a few days ago, I was traveling to Cape Town, and I was traveling at 120 kilometers an hour. Obviously, you're saying 120 kilometers an hour, you are talking speed, and you're talking speed, you are talking a scalar quantity, because it can't be a vector quantity, there's no direction. I'm just traveling at 120 kilometers an hour, but I'm not telling you where I'm going. And because it is a scalar quantity in that context, the question is how much time will it take me to travel from Pretoria to Cape Town at 120 kilometers an hour? Hypothetically, let's say we don't stop, we don't need petrol. And hypothetically, let's say I'm a robot and I don't need to stop and breathe. So if I'm traveling at 120 kilometers an hour from Pretoria to Cape Town, it takes me plus minus 10 and a half hours to get there. But now I'm flying from Pretoria to Cape Town. If I'm flying at 875 kilometers an hour, it means I am covering 870 kilometers in 1 hour, because that's what speed is. Then it takes me 1 hour, 30 minutes to get to Cape Town. As I increase my speed, what happens to my time? It decreases, right? So we say speed is inversely proportional to time. As you increase one quantity, the other quantity decreases. So as I was driving in a car, I was actually slower than when I am flying in a plane, which means as I increase my speed, my time is decreasing. Is this as confusing to you as it is to me? No, it is not to you, but I think it is to me. Let me try and unpack this so that you can see what I mean. I grew up in a society when I was told that if you have much, then you are rich. But now I am told that if you have little, you are fast. Are you with me? So it means that as my time is decreasing, somebody is saying, hey, you are fast. If we are both running from this point to that end, and you get there in 0.2 seconds, and I get there in 60 seconds, you have won, you who has less time. But if we convert that time to money, you would have 20 cents. And I would have 1 rand. I would be richer than you. And I grew up in a society when we were told that those who got position 1 in the class, I don't think you do positions, do you? Not really, right? So if you got position 1, you were very intelligent, and if you got position 10, you're actually not that, you are not the sharpest tool in the shed, right? But if we converted that to millions, you who got position 1 would have 1 million, and I who got position 10 would have 10 million. So this concept of quantifying in science is quite interesting. And today, as we talk climate change, we are actually talking about quantities in terms of temperature. But what is really confusing about these quantities in terms of temperature is what is causing those temperatures to increase. Is it that they are increasing naturally? Or is it that we have a hand as humans? And somebody actually says, after every 100,000 years, there is bound to be climate change. Regardless of what you or I do, there will be climate change. But the rate at which it is happening is much faster than it is expected. I will not get to that. Because I think there are other presentations, we should not all be talking about one thing. I will try to focus on the other side. So I was still going to Cape Town. And I got there in 1 hour, 30 minutes, because I had increased my speed from 120 kilometers an hour to 840 kilometers an hour. But if I travel at the speed of light, at 300,000 kilometers per second, let me stop there, because I want this to gravitate. If I travel at the speed of light at 300,000 kilometers in 1 second, I would have left Humansdorp today and got to New York yesterday. So if I travel at the speed of light, I defy time. Albert Einstein says, if you travel at the speed of light, you emit light. So if you travel at the speed of light, you become light yourself. Because you are traveling at the speed of the thing that gives time. You are traveling at the speed of the thing that gives light. You therefore become light. You emit light. If you are traveling at the speed of the thing that gives time, time has no control over you. How old are you still? Yes. 17. Are you sure? Well, why am I asking this question? You will see why I'm asking him the question. Because somebody was born at the same day and time you were born, but they are younger or older than you. Doesn't make sense, right? So how do I get to New York yesterday? Well, you all know about time difference, right? So we are 7 hours ahead of New York, and When you woke up at 7 o'clock this morning, if you're -7, it was 12 o'clock in New York, right? So if you woke up at 5, it was 10 o'clock. You were on a Tuesday, they were still on a Monday. Are you with me? So if you're traveling at the speed of light at 300,000 kilometers in a second, you can live here on Tuesday and get there on a Monday. You would have broken the barriers of time because you would have gone back in time. So if you had your birthday on a Monday, you then can leave South Africa a day after your birthday and have your birthday again. But it would have been yesterday, but it is actually today. And if you travel at the speed of light, exactly the same way we are saying, you are 8 hours behind Australia. 8 hours. So if you wake up at 5 in the morning, it is 10 o'clock in New York, but it is actually 1 o'clock in Australia. So if you wake up at 5, you're like, okay, I want to go to New York. I want to go back to yesterday. And then you travel at the speed of light, you get to yesterday, but when you are in yesterday, you then go to tomorrow and come back to today. I know I'm talking a lot of nonsense, okay? But you know what? This is the nonsense that contextualizes your content and that makes your science interesting. Because you're like, really? Can I travel at the speed of light? If there is anything I will tell you, is the message at the end of this presentation. But before we get to that message, can I tell you that the life science teacher has got a different idea of what we just spoke about. I have light from the sun. This light is trapped by the leaf. And as it is trapped by the leaf, inside the leaf there's a cell, and inside the cell there is a chloroplast, which is a cell organelle. Inside the cell organelle there is chlorophyll, which is a pigment inside the chlorophyll, which is inside the cell, inside the leaf. And as the sun shines, it shines on the leaf, and the chlorophyll only uses from red up until green. So you know the spectrum of light, which is Roy beam, it uses from red to green. And all of the light is attracted in different wavelengths and speeds, right? Now, the light science teacher says that light is used by the plant to create food. And when it creates food, it uses it as radiant energy. But beneath the very same leaf are openings, and these openings take carbon dioxide from the atmosphere. And as it takes carbon dioxide from the atmosphere, there is a reaction with the water that is drawn from the ground. So you have water and carbon dioxide with radiant energy, and they create a carbohydrate, C6H12O6, which is usually almost a glucose. And then on the other side, you have oxygen, which is also an end product of photosynthesis. Are we still together? Now, to be a little technical, we then have a chemical formula. And I'm talking to very intelligent people, so it's going to be easy to just say this. We have CO2 plus H2O, and you have a reversible reaction, well, in an ideal world, where you get C6H12O6, but it is actually CXHYOZ, because that carbohydrate can be anything. So we don't put 6 and 12, and because it could be C12, H24, and O12. But the ratio is always 1:2:1. Are we still together? And the oxygen. And then that oxygen is the one that we breathe in and we use, etc., etc. But then the life science teacher, who has a different idea from just what we spoke about in physics, says the sun gets to the leaf after 8 minutes. 8 minutes? I mean, we just broke the barriers of time in physics. We were traveling at the speed of light and would leave today and get to New York yesterday. We broke the barriers of time in physics, but in life science, the light takes 8 minutes to get to the leaf. Really? So the sun or light must be slower in life science than it is in physics. But then let's not challenge the teacher. We now go to mathematics because we need an explanation of what is going on here. And then the mathematics teacher says, actually, there is nothing wrong. The understanding is the same because we need to be able to do a calculation. So that calculation is finding what the distance between the sun and the earth is. Because that will justify why the light takes 8 minutes to leave the sun to get to the leaf. So what do we know? We know two things. We know that the speed of light is 300,000 kilometers per second, but we also know time is 8 minutes. So if you go back to your grade 8, you were told speed is equal to distance over time. Speed you know, time you know. What is the speed? Now, I know you don't have books and pens, but those who do, I am giving you 5 seconds to get the answer and you get a gift. If you don't have a book, I have a book. As long as you have a pen, I can give you a piece of paper. So just raise your hand if you need a piece of paper. Anyone who needs a piece of paper?
Cuando a ti te pusieron
Please make sure that your answer is in kilometers, right? Distance in kilometers, not in meters. I beg your pardon? Must I repeat? The speed is 300,000 kilometers per second. And your time is 8 minutes. You already see the trick if you are a scientist. Okay? There's a trick there. Oh, we got the answer. We got the answer. Please give a tap out. So the trick is that you have speed in 300 kilometers per second, but you have 8 minutes. You can't work with minutes and seconds in the same calculation, right? So what did we do? We converted the minutes into seconds. What do we do? Do we multiply or divide? Why don't we multiply? Please help me. I don't think I understand. Which one is bigger, minutes and seconds? Minutes are bigger than seconds, right? So it means that the value you must get must be bigger than 8, right? So in order for the value to be bigger than 8, are you going to multiply or divide? Multiply. So we multiply by 60, and it gives us 480, right? So it's 480 multiplied by 300,000, and it gives us 1. I like that. You go for something like our previous president. So it is 144 million kilometers. And that is why it takes 8 minutes. Now think of that distance. 144 million kilometers between the sun and the earth for it to get to the leaf. But when you are talking about breaking the barriers of time, it's the same earth. It is this side of the world and this side of the world, but it is the same world. But you are talking about the sun and the earth. These are two different entities altogether, and the distance is vast between them. Now, if it takes 8 minutes for the sun to get to the leaf, and we break the barriers of time, it means it is always very important to look at the distance when we calculate the speed, right? I'm going to tell you very sad news. And the sad news is that no one has traveled in time. No one has ever been to yesterday, and no one has ever been to tomorrow, even the prophets themselves. They've never been to tomorrow, they've never been to yesterday. This is only mathematically true. You can do a calculation that shows you that you can time travel, but no one has sat and gone to yesterday and said, hey, I went to yesterday, it was so nice. I went to tomorrow and I know I'm going to be rich. No one has done that. But you see, in 2015, when we discovered the gravitational waves, we were a step forward to time travel. The next scientist who is going to take us to the future and to the past is sitting right here. The scientist who is going to show us how it is physically possible is sitting right here. But there are two things you need to do. One, you need to sacrifice. And you know this. There is no decorated scientist who has become the best by making time for everything. They always make time for one thing. They always focus on what is important. People like Albert Einstein had to be reminded to get married. He was so swamped by the work, he was too busy to be thinking about anything else. He was here thinking about singularity. Okay, now let's talk about special relativity. He was so swamped, and people kept saying, hey, when are you getting married? Oh, by the way, I must get married. And I don't think he had time to look around. Somebody suggested, what about her? Yeah, she's okay, bring her. What am I saying? I'm saying there is a singularity of purpose when you want to be the best. I'm not saying people should not get married, right? I am saying that when you have a singularity of purpose, you sacrifice social media, you sacrifice gaming, you sacrifice things, and you focus on the things that will make it possible for you to have the things that you enjoy. Now, if you are the best at what you do, you get paid for being the best that you do, and you can afford things that you want. Science is very, very exciting. And I hope all of you will make a contribution to society by taking us from one level to the next. Have a good day.
Dankie seuns en dokters, leerders, baie dankie. So ons gaan nou net so 'n klein stukkie vir 'n wysheid met net nog baie geduldig wees met ons. Die probleem is as jy Skype, jy moet onthou dat jy gehoor van